So, good morning everyone. I'm Hitesri Mishra, Department of Mechanical Engineering, Nilachal Polytechnic. So, today I will discuss about your chapter 6, that is your heat transfer of subject thermal 2. So, these are the content of this chapter. That is, what are the mode of heat transfer? What are the Fourier law of heat conduction? What is thermal Newton's law of cooling? What is radiation heat transfer? Stephen Boltzmann law and Kirchhoff's law. Statement, no derivation and no miracles will be discussed here. Black body radiation, definition of emissivity, absorptivity, and this is the course of diploma. So these are the content. So introduction, the heat is, what is heat and how the heat will be transferred. So you know that heat is a form of energy. So heat is fundamental transfer or move by the temperature gradient, it flow and transfer of heat from the high temperature region to low temperature region. So basically heat will be transferred if there will be temperature difference will be there or temperature gradient will be there. And where the application of heat transfer? Application of heat transfer are designing of heating, air conditioning system, refrigerator, freezer, water heater, iron, oven, and your computer, TV. So for this purpose also heat transfer, the basic knowledge of heat transfer should be needed. An efficient, energy efficient home are designed on the basis of minimizing the heat loss in winter and heat gain in summer. So for that also heat transfer is needed. Heat transfer play major role in designing of the devices such as car radiator, solar collector, various component of power plant and even spacecraft. So what are the heat transfer mechanism? The heat transfer in three different modes. What is conduction, convection and radiation. All the mode of heat transfer require existence of temperature difference and all the mode are from high temperature medium to low temperature medium the heat will be transferred. Okay. So what is conduction? So conduction is basically referred to the thermal energy, that means heat transfer that will occur across the medium which may be solid or a fluid or solid may be fluid may be, that means liquid or gases. So how the fluid energy will be transferred? Because of due to temperature difference. Okay. So thermal conductivity is the transfer of thermal energy, that is heat, from the higher energetic region to lower energetic particle of a stationary medium due to interaction between the particles. Okay. Then though I said that in the solid and fluid medium the heat will be transferred and due to temperature difference, in the in liquid and gas case, how the heat will be transferred or how the heat will be conducted? The conduction is due to the collision and diffusion of molecule during their random motion. In this way, in the gas and liquid, the heat will be conducted or conduction will be there. But in case of a solid, due to lattice vibration and the energy transport of free electron, the conduction will be happening. Okay. Next we will go for, then what is the example of conduction? So if you heat the one end of the rod, suppose I am giving, if we heat one end of the rod, if you are giving the heat, what will happen? So if this surface will be heated, then the molecule of this surface will also heated, and due to lattice vibration and transportation, so these and here also this end is your cold end. So here molecule having low temperature, here molecule having high temperatures. When these molecules are getting the energy, it will start transport. So when it will be start transport, so to fill this space, some of the molecule will be come here. Okay. So this way the molecular transport from here to there, and the one end to other end the heat will be transferred, and by the gradually the rod will be heated. So that is known as due to lattice vibration and transportation of energy of the free electron, the solid would be get heated or conducted. Then next is your convection. What is convection? Convection is a mode of heat transfer between the solid surface and adjacent liquid or gas when they are in motion. Okay. And it involves the combination effect of conduction and fluid motion. So see, here is one hot egg is there. So if you are using a blower or fan, then the air will be supplied. So when the air will be supplied, here is also hot egg where the air will be supplied. So this hot egg, suppose this is your solid surface. So and air having temperature of T infinite, that is your fluid surface. So between the solid and fluid, the heat transfer that will be occur, that is known as your, when the fluid is in motion, that heat transfer is known as your convection. Okay. Then faster the fluid motion, the greater the convective heat transfer. So more the fluid motion, greater will be the convection heat transfer. Okay. Then in the absence of any bulk fluid motion, the heat transfer between the solid surface and the adjacent fluid may be pure conduction. If fluid is not in motion, or any bulk amount of fluid is in motion, that means the fluid is not exactly come in contact with the surface, so it may be considered as a conduction. The convection is called forced convection when the fluid is flow over the surface by the external means such as fan and pump. So to cool the hot egg, if you are supplying the air by the help of your fan or any blower, then that is known as a forced convection. And due to buoyancy effect, or that is the density difference, if the fluid will be flow, that will be known as your natural convection or free convection. So free convection is the process of heat transfer which occurs due to the movement of fluid particle by the density change associated with the temperature difference in the fluid, that is known as your free convection. So if you are using a pump, a fan or blower, that will be known as your forced convection. Okay. Free convection flow velocity is encountered lower compared to the flow velocity in forced convection. Then velocity that will be free convection is less or lower compared to lower than that of the free convection. What are the example of forced convection? Air cool IC engine, the air cool engine is your bike engine, air conditioner, heat exchanger. These are the convection, forced convection, or you can say free convection also. Then we go for radiation. What is radiation? Radiation is the energy emitted by the matter in the form of electromagnetic wave or photon as a result of change in electromagnetic configuration of the atom or molecules. So unlike conduction and convection, the transfer of energy by radiation does not require the presence of any intervening medium. So this is called as a radiation. What is the example of radiation? Sun radiate heat to the earth, that is radiation. What is Fourier law? Fourier law of heat conduction or thermal conductivity. What is Fourier law? It states that rate of heat transfer per unit area is directly proportional to the temperature gradient. So we will mathematically say rate of heat transfer Q per unit area is directly proportional to the temperature gradient, that is dt by dx. Mathematically we can write like Q by A is directly proportional to dt by dx. So if I remove the proportionality, then Q by A is equal to minus K dt by dx. What is minus? Negative sign indicate increase in thickness. If the thickness will be increased, then the temperature is decreases. So what is a Q? Q is a rate of heat transfer in watt or kilowatt. Q by A, that is a small q, that is heat flux, watt per meter square. Then thermal conductivity, watt per meter degree centigrade or watt per meter Kelvin. And what is area? Area is a normal to surface, that is meter square, dt by dx, that is your temperature gradient. Then what is thermal conductivity? Thermal conductivity is the property of material which is defined as the ability of material to conduct heat through it. Okay. So if you consider the aluminum and the steel, so which is heat carrying capacity is more? Aluminum. So we can say that the thermal conductivity aluminum is good. Okay. Higher the thermal conductivity, higher the heat conduction. Okay. So now what is the unit of thermal conduction? Thermal conductivity, that is watt per meter Kelvin or watt per meter degree centigrade. Okay. That's all.